All right, good afternoon, everyone. It is day 7 of the Algebra 1 10-day EOC review. Today, you're going to be looking at investigating, describing, predicting the effects of changes of M and B on your equation. So we're really looking at slope and y-intercept and how we change those things. Like when you manipulate it, when you change the slope a little or change the y-intercept of it a little, how does it affect the graph, right? Let's look at the very first part here. But something to know before we get started is two things. One thing is that the number that's always in front of x is always your slope, right? That's always your slope. And the number that's off to the side there, that is what's known as your y-intercept, right? So the y-intercept's a real easy person, right? The y-intercept basically represents what is your start, and the slope represents the rate of which the graph is increasing, right? One represents where you start, the other one represents the rate. So let's go ahead and put the starting place. The starting place is not just 3, but -3. Cannot forget that negative. So we're going to put a point right here at -3. Let me just count. 1, 2, 3. This is 3 right here. So we're going to start at -3. We're going to put a nice good point to clarify we're starting there. And then we're going to have a rate of 2. Now, the thing about slope is rise over run, right? That's what slope basically is. It's how much you go up and how much you go over. Well, it says 2, which definitely means that I'm going to go up 2. But how much am I going to go over? Well, truth be told, all whole numbers, any whole number, like the whole number 4,681, that big number, it's really a fraction. You know what it's over? It's over 1, right? All whole numbers are over the number 1. So 2 is really 2 over 1. That means we're going to go up 2, right, over 1. Put a point. Up 2 over 1. Put a point. Up 2 over 1. Put a point. And you get the picture, right? Over 1. Up 2 over 1, right? That's what it means. Rise 2, run 1. Real easy. I'm going to go ahead and go backwards too. Right? Backwards, we're just kind of looking at the line, making sure I'm following up the line, you know. That way I have some extra space there. And now you're ready to draw your line. Don't forget, the key thing is you start at your y-intercept and you follow the slope's directions, up 2 over 1. You always start at the y-intercept though. Y-intercept is your start. So that's question number 1. Real easy problem, all just for you. Look at question 2. Gets a little tricky. Using the function in question number 1, you're going to multiply the slope by negative 0.5 and increase the intercept by 8. The y-intercept by 8. Graph the new function. Well, this is not so bad. I mean, you already could see your y-intercept. Your y-intercept is down right here. If you don't see, I'll erase, make it a little clearer again. Your y-intercept was right here. And you're going to increase that by 8. So simply increase it. Or you could do adding it, but since it's here, let's increase it by 8. 1, 2, 3, 4, 5, 6, 7, 8. Look where you landed. What number did you land? Right? That's increasing it by 8. So I need to transpose this to the other side. Okay, there you go. Let's put this on the other side. I was at -3, and you went up 8. So let's see. That's exactly 1, 2, 3, 4, 5, 6, 7, 8. Right? We got 1, 2, 3, 4, 5, 6, 7, 8. Okay. And there's your new point. This is your new y-intercept. Let me see. I'm going to draw this. That's your new y-intercept. Right? Y-intercept increased by 8. Done. So now that we've increased the y-intercept by 8, now we need to multiply the slope by negative 0.5. Now look at the slope before. The slope before was 2. Right? That was your slope before, 2. So now we're going to grab that 2, and we're going to multiply it by negative 0.5. By the way, 0.5 is the same thing as saying half. So basically what it's really asking you for is what's half of 2? Half of 2 is 1, and since that's a negative right there, you're going to have to say negative 1. So now I got the answer, negative 1. Okay, so negative 1. Let's see here. Where am I going to put that one? Negative 1. Ah, yes. I forgot. You start at the y-intercept, right? And then you do the new slope. This is your new slope, right? That's your new slope. So you're going to start at the y-intercept right here. Let me just get rid of those lines. I don't like those lines right there. Go away. And then you're going to do a slope of negative 1. Don't forget that negative 1 is the same thing as saying negative 1 over 1. So which means instead of going up 1, you're actually going to go down 1, right? Down 1 over 1. Down and put a point. And down 1 over 1, put a point. Down 1 over 1, put a point. Down 1 over 1, and so on. You get the point. That's how your new line will look. You can go ahead and put some going backwards. All right, and there's your new line. Okay, not bad. Let's move on. All right, write the equation for function number 2. Question number 2, beg your pardon. We'll just draw a new line. I'll let you handle it out. Don't forget that it always goes y equals slope x plus something. I want you to go and fill in the gaps. Don't forget that whatever's next to x is slope. Slope is always next to x. Always next to x. All right? And the y-intercept is the other guy. Fill in the blanks. I think you could do that. True or false? Two functions with the same slope values are always parallel. Explain your answer. Now, if you really want to judge a statement that two equations with the same slope are always parallel, this is what you could do to test that. If you don't know it, right, true or false, this is what you could test, especially since you don't have a graph calculator at home. Here's what you could do. I want you to graph these two equations. Let's make up a y-intercept right now. Let's say let's say one y-intercept is 2. I want you to make up any slope. And what we're going to do, and let's make the other y-intercept, say, 5. Yeah, 5. All right. You know, let's make this 1. And this one 4 instead. That way it's a little lower. All right. So make up any slope you want to. You can make it up as like 3 over 2, or you could make it up to be, I don't know, 1 over 2, or you could do even, I don't know, 1 over 3. But basically, what I want you to do is I want you to graph these two to test. I want you to test if parallel, right, by graphing them. All right, that way you could see, is it true or false? You see, right, by doing something different. You could try any slope you want. Just make sure they're the same. You can do a negative slope, like negative 2 over 3. Just make sure that these two guys have to be the same. See if they're the same slope. Are they parallel? You try it out and let me know true or false. Try it out. All right, guys. Hope that was helpful. Y'all have a good rest of the evening.